In example 3, we want to find the z-score that represents the 5th percentile. Thinking back to lesson 8, the 5th percentile is going to be the place in the data where 5% of the data is below that. So there should be shaded to the left, and I'm shading to the left because 5% of the data is below that, a left area of 0.05 or 5%. And what we are trying to find is we are trying to find this z-score. I hope everyone sees that that z-score must be negative because it's to the left of 0 because that area is less than 50%. So one thing we could do is we could come to our standard normal distribution table and we could look for in the table, because in the actual table, these values in here, I hope everyone understands this. Please, please, please email me if you have a question about what I'm saying right now. What I'm highlighting in green are probabilities or areas. What I'm highlighting in pink is where we get the z-scores from. Okay, we are starting with a green number. We are starting with a probability, an area of 0.05, and we need to go find the z-score that matches up with that. So what I'm looking for in the table right now is which of these values is closest to 0.05. So I see 0.0, no, that's 0.00. That's not going to work. Psych. Moving on, 0.05. Okay, here we go. I see 0.0505, which is not quite what we want, but I also see 0.0495, which is also not quite what we want. But what we want of 0.05 is directly in the middle of those two numbers. What we want is directly in the middle of those two numbers. So what I'm going to do is I'm going to look up the z-scores that correspond to both of them, and then we're going to average those z-scores together. So 0.0495 matches up with negative 1.65, and 0.0505 matches up with negative 1.64. So I'm going to add those two numbers together and then divide that by 2. I didn't plan for this. Add negative 1.64. We get negative 3.29. And then I'm going to take that negative 3.29 and I'm going to divide that by 2 to get that they have an average of negative 1.645. And that is our z-score. That has a left area of 0.05. We could not find 0.05 in the table exactly, and that will happen sometimes. If you're using the table exclusively, you will run into problems where you cannot find the probability that you're looking for exactly. If the probability that you are looking for exactly, we were looking for 0.05, that is smack dab in the middle of 0.0505 and 0.0495. So we found the z-score that corresponded to this one, which was negative 1.65. We found the z-score that corresponded to this one, which was negative 1.64. And then we averaged those two z-scores to get that the z-score that's corresponded to this one was negative 1.645. Okay, so that we've seen how we could do this problem with the table. Now let's see, how could we do this problem with the calculator? So if I was doing this problem in my calculator, I would need to be going back to my mnorm function. When I open that up, it's going to, so I hit second vars to get to distribution and I go down to mnorm. It's going to ask me for an area and it's asking me for a left area. We have a left area of 0.05. Mu and sigma are still 0 and 1 respectively, and we still get negative 1.645 approximately. It's okay if it's off a little bit. Technically, this is negative 1.64 because it would round to negative 1.64, but that's perfectly fine. So we would put in our left area first. The calculator is already going to go ahead and give us 0 and 1 for mu and sigma. And we get negative 1.644. This is right. This is right. Perfectly fine. And the last way I will show you how to do this problem is on StatCrunch. Okay, so I've pulled up StatCrunch. I'm going to go to stat calculators, and I'm still going to my normal calculator. What we were doing before is we were putting in values here, like negative 1.645, and it would tell us, oh, it has a left area of about 5%. But that's not what we're doing anymore. I'm just going to open up that calculator again. What we're doing now is I know the area. I know what the probability should be. I want to know what the z-score is. So I know that the area should be 0.05. And now I click compute, and it draws me a little graph where I can see a shaded red area to the left of 0.05. And then down here, it's giving me what that z-score is of negative 1.644. Or same thing we found earlier. So I'm just going to pull a little screenshot of this over, because sometimes you might be doing work on like a project or a lab or something. If this is what the method that you use to find your z-score, then you just turn in the screenshot to support your work. So when I see this screenshot, which I'm going to move over here a bit. When I see this screenshot, I look at this and I can see that I look at this and I can see that you had to enter in this left area. You put that in, and then StatCrunch gave you that answer of negative 1.644. So you could either get your answer on the calculator. If you get your answer on the calculator, you would write this on your paper to show me your work. If you did your answer on StatCrunch, you would give me a screenshot of that. And if you just used the standard normal distribution table, you would probably just have a picture or something like that. You may, if you're only using the table, you may make a little table where you tell me, hey, I know the left area is, don't make that mistake, 5%. I want to know what the z-score is. And then you would go look that up. There's not really a lot of work you can show me if you're using the standard normal table. Let's look at our last example under this objective. This time we want the z-score that represents P90. P90 is the 90th percentile, which means that I am looking for the z-score that has 90% of the data to the left. Percentiles always tell you how much data is on the left, because percentiles tell you what percentage of people did what percentage of people did worse than you, scored lower than you. So we have a left area of 0.9. One thing we can do, we can come over to the table. We're definitely looking for a positive z-score this time, because 0.9 is bigger than a half. We could come over to the table. We're looking for 0.9, as close as we can get to 0.9. So I see 0.8997. That's as close as we're going to get to 0.9. This one, 0.9015, that's a little bit more further away than 0.8997 is from 0.9. That's only like 0.0003 away. So when this is the closest value, I don't have anything to average here because there's nothing else that's equally spaced away from what we're looking for. So I would just go and grab my z-score of a positive 1.28. 1.28. So that is how we would do this problem if we were using the standard normal table. Using the standard table, we started off, we knew we were looking for a left area of 0.9. We went to the table and looked up the z-score and got 1.28. If we were using our calculator, we would hit second bars to go to our distribution menu. We would select in the norm. We have a left area of 0.9. And we would hit enter twice on this, and the calculator would also give us 1.28. So in the calculator, and again, you don't have to do all these methods. You just really got to do one of them. I'm just showing them all in the video, so you all can pick whatever it is you want to use and go use it. If we had decided to use StatCrunch, I would go here and I would enter in what the left area was, which was 0.9, and then I would compute that, and it would tell me, well, hey, if your left area was 0.9, your z-score was 1.28. And we can see that pop up down there at the bottom. So in StatCrunch, it would also give me an answer of 1.28 after we entered in all of this left area of 0.9.